Alright, so this video is about graphing just with sine graphs. And what we're dealing with is just horizontal shifts, or what we call a period shift, if you will. Okay? And we're just going to be dealing with, again, what does a sine graph look like normally? And then based on the horizontal shift or the period shift, what happens to the graph? Okay? But just like any other transformation of a graph, it could be a polynomial, it could be an absolute value, cubic, quadratic, whatever it is, it follows the same rules. Okay? So the way I like to think about it is, whatever's with x or whatever's within my variable, you do the opposite of what it says. Okay? So like on number 1 here, and by the way, I use my fantastic acronym, rigorous, or as I'd say, really good rib sauce. Okay? You're like, what in the world does that mean? Okay, what that means is the R stands for realize. Okay, we have to realize what kind of graph this is. Okay, obviously it tells me flat out this is a sine graph. Okay, now a sine graph, what it typically looks like is that it starts at 0, 0. Okay, it starts at 0, 0, and then at it looks something like this. At pi over 2, it gets up to 1. At pi, it goes back down to 0. At 3 pi over 2, it's at negative 1. And at 2 pi, it's back up to 1. Okay? So that's what a normal sine graph looks like. Okay? Without any shifts or any changes, this is what a normal sine graph looks like. Okay? And that's what I did. I graphed. That's what the G stands for. Graph. Okay? And then the R stands for reflection, which I don't see a negative involved in front of the equation, so I don't need to reflect it. That's fine. And then the S stands for shift. Okay? So now I have to deal with the shift. So, yes, there is a shift right here, this plus pi over 3. Okay? And a plus sign, we usually think, oh, that's positive. We go to the right pi over 3. But what this really means is that we go to the left pi over 3. Okay? Which is sort of weird, right? Because you're like, okay, what does that mean? All right, let me go ahead and try to explain. So normally a sine graph starts at 0, 0, correct? Okay? Usually starts at 0, 0. But this time, it says go to the left pi over 3, so it's actually going to start here at negative pi over 3. So this is where my sine graph is going to start, right? Because I shift left. So my usual starting place is at 0, 0. So I'm shifting my starting place to negative pi over 3. All right? But now I need to find my new kind of landmark points. Because for the red graph that you see, how I went up to pi over 2, then it curved down to pi, continues going down 3 pi over 2, then comes back up for 2 pi. Okay? We have to be able to know where those landmark places are. Okay? And notice that that is the gap. Okay? So if I were to write it like this, pi over 2 is 1 pi over 2. And pi right here is 2 pi over 2, which we reduce down to 1 pi. Okay, then I have 3 pi over 2. 4 pi over 2 is actually just 2 pi. Okay? But you see how each milestone is a pi over 2, which in degrees means 90. So every 90 degrees, or pi over 2 radians, there is a significant point in the graph. Okay? So what I need to do is, assuming I start at 0, okay, I move back to negative pi over 3, and I need to find my new milestone points, or my new tick marks I need to make on the graph. So what I do is, I add pi over 2 to each place. So if I'm starting at negative pi over 3, so negative pi over 3, I'm going to add pi over 2 to it. Okay? And that will tell me where my next significant line is, where my graph goes. Okay? But of course, if I'm using fractions, I have to have common denominators. The common denominator between 2 and 3 is 6. So I need to multiply this by 2, multiply this by 2, multiply this one by 3, So this would be negative 2 pi over 6 plus 3 pi over 6. Okay? Then negative 2 pi plus 3 pi equals 1 pi over 6. Okay, so on my graph over here, I'm going to go to pi over 6, which we could just make an estimate here. It's going to be about here. So this is going to be pi over 6. Okay, so it's about there. All right. All right, so then at pi over 6, we add another pi over 2. Okay. So from pi over 6, we add another pi over 2. Again, we have to have a common denominator, so common denominator is 6, so multiply by 3. So 1 plus 3 is 4 pi over 6, which I reduce down to 2 pi over 3. Okay. So 2 pi over 3, if I had to guess, it's just short of 1, so I'm going to say it's about there. So there is 2 pi over 3. Okay. And then with 2 pi over 3, we add another pi over 2 again. Okay, common denominator, as we know, is going to be 6. So multiply by 2, 3, and 3. So I would have 4 pi over 6 plus 3 pi over 6, which equals 7 pi over 6. Okay, 7 pi over 6 for this graph would be just past pi, so 7 pi over 6, somewhere like right there. Something like that. 7 pi over 6. Okay, so my new graph with the shift starts at negative pi over 3 and then goes up until it gets there. It goes down, hits 0 here. Goes down until it gets to about here. And then swoops back up right about there. Oh, wait, I forgot about the next point. So I had to do one more. I'm sorry. So we're at 7 pi over 6, and we have one more. So 7 pi over 6 plus pi over 2. Okay, common denominator is 6, so times 3 times 3. So I have 7 pi plus 3 pi, which is 10 pi over 6, which really is, that would be 5 pi over 3. Okay, and 5 pi over 3 would be about here. 5 pi over 3. Okay, so it starts at negative pi over 3, goes up, hits 0, goes down, then comes back up. So the green graph is the same as the red, except obviously it's moved over just a little bit. Okay? So I know that was kind of long, you're like, I'm really kind of lost. I would encourage you to go ahead and pause the video, go back, so that you can see how I did it again. I'm going to do it now for the second graph here. I'm going to do it for number 2. Okay? So for number 2, realize what kind of graph it is. Well, it's a sine graph. Typically for a sine graph, okay, starts at 0, 0. It's going to go up here, come back down to pi, come down at 3 pi over 2, then it comes back up at 2 pi. Okay, that's what a normal trigonometric function looks like. All right, so now that we have our parent function set, let's go ahead and get all of our shifts set here. Okay, so I notice that there's a plus 4 pi over 3. Okay, what that means is we do the opposite of what's with x or whatever's with the theta there. Okay, so we actually go to the left 4 pi over 3. Okay, which means my new graph, okay, is going to start actually out here at negative 4 pi over 3. Okay, so my usual starting place is at 0, 0. Okay, but now I'm starting at 4 pi over 3. Okay, and what we do is we add pi over 2 4 different times to find out where my new changing points are, where my new critical points are. Okay, so starting with negative 4 pi over 3. Okay, here we go. So negative 4 pi over 3. I'm going to add pi over 2, which of course we have to make common denominators. So times 2 times 2 times 3, 3. Okay, so that's going to give me negative 8 pi over 6 plus 3 pi over 2. Excuse me, 3 pi over 6. So negative 8 plus 3 is negative 5 pi over 6. Okay, so that's critical point number 1. So negative 5 pi over 6, we'll say that's about here. So negative 5 pi over 6. Okay. All right, let's move on to the next one. So we add pi over 2 to that. Okay, so we just got to multiply the second fraction times 3. Okay, so times 3 times 3. So negative 5 pi plus 3 pi actually gives me negative 2 pi over 6, which is just negative pi over 3, right? Negative pi over 3. Okay, so if I had to graph that, that would be about, well, it's not really a great graph, but so negative pi over 3 would be about there, we'll say. Okay. If we keep going, okay, so negative pi over 3 plus pi over 2. Okay, we had to change both of these this time. So times 2, times 2, times 3, times 3. So negative 2 pi plus 3 pi gives me pi over 6. Okay, so pi over 6 would be about here. So that's pi over 6. Okay. And then, one more time, this is the fourth time, last time, we had pi over 2 to this, but we have to multiply by 3, and then 1 plus 3 would be 4 pi over 6, or 2 pi over 3. And 2 pi over 3 would be about here. Okay, so on my new graph, here we go. It starts out here, comes up, crosses 0, comes down, and right there. Okay, so actually I made that a little bit too high. Let's go back here for a second. So because it only goes up to 1. Up here, down here, and then up like this. So you notice that the whole graph has been shifted, and I just moved it over a little bit right there. Okay, so that's basically how you do it. So you graph the parent function, and then using the shift, you move it over, and then you have to find your new anchor points by adding pi over 2 4 different times, and then you'll be able to get it.